In this video, we continue the study of our 5 important lemmas. We are now up to lemma 4. Before stating lemma 4, I want to review what the previous 3 videos established. Our first lemma said that if we are in a group and we happen to have an element and we triangle with itself, so A triangle A is equal to A, then we know that A is actually the right identity in the group. The second lemma said that right inverses are actually two-sided inverses. In other words, if we know that A triangled with A hat is equal to ER, then we also know that A hat triangled with A is equal to ER. And our third lemma says that the right identity in axiom 3 is actually a two-sided identity element. And what this says is that for all A inside group G, we know that A triangled with ER is equal to A, but we also know that ER triangled with A is equal to A. So we're now ready to state lemma 4. And lemma 4 says the identity element in a group is unique. Now, before proving this, again, I want to think about what does this actually say in terms of symbols and how to think about going about proving it. So let's think about what this says. We already know that ER is an identity element, and it in fact is a two-sided identity element. Well, let's suppose something like E hat is also an identity element, and it doesn't really matter what kind we're going to suppose. I'm going to think of it as a right identity element, but it could be a left identity element, and the proof would run very much the same way. So we've got two of these things that are trying to be identity elements, and what we want to do is we want to show that they are actually the same object. Because if we can show that the two things that are supposed to be identity elements are the same object, this is enough to say that ER is unique. This is a standard way of proving uniqueness. You assume that you have two things that work and you show that they are one and the same thing. So let's now actually work on the proof of lemma 4. So we know from axiom 3 that A times ER, A triangle ER, is equal to A for all A inside the group G. We also know from lemma 3 that ER triangled with A is equal to A for all A inside group G. We are going to assume that E hat is also a right identity element. Inside our group G. Now that says two things. It first of all says that E hat does belong to G, and second of all, it says that anything triangled with E hat is going to be the anything. There's one other thing that I also ought to point out, and this is a thing that we know. We also know that ER belongs to G, and that's also relevant. Now what I'm going to do is I'm going to look at this expression. I'm going to look at ER triangled with E hat. Now, I want to think very carefully about this. Looking at lemma 3, so I kind of want to be focusing in on this idea. I know that ER triangled with anything in G, and E hat is in G. And so E hat can be placed in for this up A up here, and this becomes ER triangled with E hat becomes equal to E hat. So this expression will be equal to E hat by lemma 3 and the fact that E hat belongs to G. But I now want to look at that same expression with slightly different eyes. So I'm going to rewrite this down again. And I want to think about this guy here. This guy is known to be a right identity element. And of course, ER is inside G. So in this expression up here, we can place ER in for the A. So this expression up here becomes ER triangled with E hat is equal to ER. In other words, this expression is also equal to ER. Now all I have to do is put the two things together. And when I put the two things together, we get this. We have the following. I want to give myself just a little bit more room. I'm actually going to start here, go this away, that's equal to this, and go this away. So what we have is this. We know that E hat is equal to ER triangled with E hat, and this is by lemma 3. And then we also know that this expression is equal to ER, and this is because E hat is assumed to be a right identity element. But look at what we've got now. That is actually saying we have E hat and ER are exactly the same thing. And what that says is ER is the unique identity element inside our group G.